Okay guys, now let's talk about adding or subtracting rational expressions. So objective 1, add or subtract rational expressions with a common denominator. So to add or subtract rational expressions with the common denominator, we use the following property, right? So a over c plus b over c just equals a plus b over c. Same thing with subtraction, a over c minus b over c equals a minus b over c. So you can just use the same denominator, right, once, and then combine the tops. That's what you do. Where a over c and b over c are two rational expressions, c can never equal 0, right? We know no 0 in the denominator, and then we simplify the result. So perform the indicated operation, which is addition, for this equation, and we know that x cannot equal negative 3/2, because if we set 2x plus 3 not equal to 0, well, we get that x cannot equal 3/2. So that's going to be our restriction on this one, okay? So we're going to add the numerators and write the result over the common denominator. And our common denominator is going to be x, or 2x plus 3. Can't even read. Okay, so we're going to add our numerators. So it's going to be x squared minus 3 plus x squared plus x, all written over 2x plus 3. And we only write that once because that's our least common denominator, right? So now we can combine everything. So when we combine those, we have 2 of these, so that's going to be 2 x squared, and we have plus x minus 3, and then all of that, I'm going to have to draw this in here, is going to be written over 2x plus 3. Okay? Now, it says factor, well, I said combine like terms, but we did that. I'll just do it all in one thing. Sorry. There you go. Now we're going to factor the numerator. So I'm going to try to do that on this line like I'm going to do that here, because that's just kind of how it flows for me. I'm sorry, I don't just follow these steps very well, do I? So we're going to factor this. So we know we have 2x, and then this has the coefficient in front, so it's going to be the AC method, right? So 2 times the negative 3, the absolute value bar is going to equal 6. Well, the factors of 6 that equal a positive 1 are going to be 2 and 3. It's going to be positive, so the larger gets the plus, right? And this one gets the minus. So bring the first one down and the last one down, so we know it's going to be 2x squared minus 2x plus 3x minus 3, right? That's the factors of this guy. Now we can factor by grouping because there's 4 terms. Greatest common factor from the first is going to be 2x. That's going to leave us x minus 1. Greatest common factor from here is going to be positive 3, and that's going to leave us x minus 1. So now we can see what our factors are for the top. Let's change colors again. Let's go to pink. So we're going to have 2x plus 3 is 1. And then x minus 1 is the other. And all of that is written over 2x plus 3. Okay? Now, our next step is divide out common factors and express the answer as a simplified rational expression in factored form. Let's grab our blue and do our cancellation. Our 2x plus 3 will cancel, and our final answer is going to be x minus 1. Okay, that's how you do it, guys. Let's do another one. Now we're going to perform the indicator operation on this equation. Notice that this is the difference of squares, right? So we know that x can't be positive 5 or negative 5. This one is very similar, but it's not exactly the same. So we need to do a little math games, right, to make it be the same. So we notice if we move this around, like let's try to rewrite it to where it's similar. So that would be negative x squared plus 25, right? So we just have both of these are different signs, so we can factor out a negative. So that's what they're telling us to do here. Factor negative 1 from 25 minus x squared, and then we could use this fact, that a over negative b is the same thing as negative a over b. So that's what we're going to do. We're going to factor out a negative 1, and we're going to apply it to the top, okay? Which is So then that would give us a greatest common, that's not true, a least common denominator of x squared minus 25. Right? Okay, so let's do that. So we're going to have x squared minus 11, and then we're going to say plus, just like we have here. But when we factor this negative out, I'm going to write him right here. Alright, times, that's a negative 1, and then I'm going to put this guy in parentheses, negative 3x minus 1. That way you can see all of my steps, and it's not really confusing. Now, since I factored this negative out, I can write this guy as x squared minus 25. So our least common denominator now is x squared minus 25. Okay. Now I have to distribute this negative 1 to all of these. So this is going to be x squared minus 11. This is going to be plus 3x plus 1. And all of this is still over our least common denominator, which is x squared minus 25. Now we can combine like terms. Okay. So we'll have x squared plus 3x minus 10 over x squared minus 25. Alright, so now we can factor the top. We know there's two x's. Factors of 10, they give us 3, well that's going to be 5 and 2, right? The bigger one's going to be the positive, so that's going to be x plus 5, x minus 2, and we know that difference of squares is going to factor to be x plus 5, x minus 5. Alright, we can make that jump. Y'all are good enough to do that? I know you are. Alright, so now our x plus 5's cancel, leaving us with x minus 2 over x minus 5. Right on. Okay, next one. So we're going to list the steps for finding the least common denominator. I listed it my way. So, they're stuck with my definitions, I guess, or my steps. So to find the least common denominator, I always factor completely. And what I mean by that is I list it in prime factored form. So, I just said number 1, factor completely. And then I put prime factored form. Oh, too big. Sorry, I should have it smaller. And then step 2, I write the factors that they share, and then the factors that are unique. So write, I'm going to put shared factors. And unique factors. So, I wrote an example so that you guys can see what I mean, because sometimes, like what I say is kind of foreign, I know. So, like, let's take 3 and 12, and let's find the prime, or the least common denominator. So, 3 is always just like 1 times 3, right? And then 12, because 3 is prime. When we know that 12 is 2 times 2 times 3. Well, what they have in common are the 3's. So when we try to find, or when we find the least common denominator, we're going to list the 3's, because that's what's in common, right? What they share. So they share a 3. And then we have a 1, but then we have a 2 times a 2 times a 1. So we multiply all these together. So 3 times 2 is 6, times 2 is 12, times 1 is 12. So 12 is our least common denominator between 3 and 12. And you can do that with more numbers, or if there's a variable. And that's how you can find your least common denominator, always. Like, it never fails, okay? Alright. So, the next one, it says, add or subtract rational expressions with different denominators. So list the steps for adding or subtracting rational expression with unlike denominators. So the first thing I always do is find the LCD. See above. Alright. Then the next thing that I do is I multiply each term by the LCD and cancel. So number 2. Multiply each term by LCD LCD, and cancel. And then let's go third. I distribute and combine like terms. And then there's a fourth. Don't want to forget this one. Super important. I solve. After you solve, never ever forget, you always have to check, right? So 5 would be check your solution. Okay. Number 5. We're going to add these two and simplify the results if possible. So what is going to be our least common denominator? Sorry guys, this cold's killing me. So we have x squared minus 4. We know that this is the difference of squares, right? So the difference of squares, x squared minus 4, that always factors to be x plus 2, x minus 2, right? It has to have different signs because the middle term cancels. So that's going to be our LCD. So it's going to be x plus 2, x minus 2. Okay, so now we're going to express each rational expression as an equivalent Express each rational expression as an equivalent expression written on the common denominator. Hang on, I got a cough. Sorry for all the pauses during this video, but it's unavoidable. Okay, so we're going to take 3 over x plus 2. Plus 8 minus 2x over x squared minus 4. Okay. Now let's multiply both sides by the part of the LCD that we're missing. So let's multiply this side, x minus 2 over x minus 2. Okay, so we're going to take 3 over x plus 2, sorry, and we're going to multiply it by the part that is missing. So we're going to multiply it by x minus 2, top and bottom. Okay, so that's going to give us 3 times x minus 2 over x minus 2 times x plus 2. That equals 3x minus 6 over x minus 2, x plus 2. Okay, I'm going to draw a little line here. And then we just have our 8x, or 8 minus 2x over x squared minus 4. So that's when you have them, I should write this, x minus 2, x plus 2. That way you can see it better. Now they're both over the same denominator. Okay? Okay, so now we're going to add and simplify the results. So now let's just add them. So we're going to have 3x minus 6 plus 8 minus 2x all over x minus 2, x plus 2. So we can combine like terms now. So this is going to give us x plus 2 over x minus 2, x plus 2. Let's cancel, leaving us with 1 over x minus 2. And this would be our solution. Okay? Now let's subtract these two. We're going to simplify the result as possible. So what is going to be our least common denominator? Well, for us to know this, we have to factor both of these. So a squared plus 12a plus 20. Well, he factors to be a plus 10, a plus 2. Alright? And then if we have a squared plus 8a minus 20, he factors to be a plus 10 and a minus 2. Right? factors of 20 give us 8, factors of 20 they give us 12. So our least common denominator is going to be a plus 10, a plus 2, and a minus 2. So a plus 10, a plus 2, a minus 2. That's our least common denominator. So let's use some math logic. We have a, and we already on a squared plus 12a plus 20 have a plus 10 and a plus 2. So a plus 10, a plus 2, that's a given, but we have to multiply top and bottom by the one that we don't have, which is a minus 2. Okay? And now we're going to subtract this side, which is just a 1. And on this side, we have a plus 10 and a minus 2. But we don't have the a plus 2, so we have to multiply the top by a plus 2 and also the bottom, a plus 2. Now, it's okay that they're not in the same order because its multiplication doesn't matter, right? Now, change colors. And we're just going to FOIL, okay? Or not FOIL, sorry, distribute. So a times a is going to be a squared minus 2a. Now, these are the same, so we can combine them on the bottom. And 1 times anything is just always itself, minus a minus 2, right? Because we got to distribute that negative into both of those. And this is a plus 10, a plus 2, and a minus 2. Okay, now we combine like terms, and we're done. So that's pretty easy to do there. Let's just go green and do it. So it's going to be a squared minus 3a minus 2 all over a plus 10, a plus 2, and a minus 2. And you don't have to multiply those out. That is perfectly fine right there. Okay? Right on. Okay, now let's do number 7. Let's find the LCD first by factoring all of the denominators. Okay, let's do number 7 and find the LCD by factoring all of the denominators. So our first one is going to be x squared minus 2x plus 1, and that factors to give us x minus 1, which equals x minus 1 squared. Okay, so that's what we're looking at there. Our second term is just x. And then our third term, which is x squared minus x cubed. Well, our greatest common factor between the two of them is going to be x squared. And then that is going to leave us 1 minus x, right? But we don't want 1 minus x. We want it in the form of x minus 1. So if we were to factor out a negative 1, we can have x squared and then x minus 1. And that's what we want. So our least common denominator, well, x squared times x minus 1 squared. So that's going to be our least common denominator, x squared times x minus 1 squared. Okay. Now we have to express each rational expression as an equivalent expression. So let's start that process. So we're going to take the first one. We know that that's x over x minus 1 squared. So in this denominator, we're missing our x squared. So we'll multiply the top and bottom by x squared. I guess maybe it's over here. So that's going to give us x cubed over x squared times x minus 1 squared. Okay? Alright, now let's work on our second term. Now our second term is simply 2 over x. So we're going to multiply him, top and bottom, by x, and then x minus 1 squared. that's going to equal, let's see if we can, it's going to be, let's multiply all that out. Okay, so it's going to be 2x. First, let's do our FOILing. So x minus 1 squared we know is going to give us x squared plus 2x, or minus 2x plus 1, right? Because it's going to give us this guy right here back. And then we're going to multiply 2x times that. So it's going to be 2x times x squared minus 2x plus 1. Right? So then that's going to give us 2x cubed minus 4x squared plus 2x. So that's what the top is going to equal. 2x cubed minus 4x squared plus 2x all over x squared, x minus 1 squared. Okay. Now, the last one, we have x plus 1. Now let's write it like it is. Negative 1 times x squared, x minus 1. So we've got to get rid of the negative 1, which would be distributed up to the top. We saw that earlier. And then we have to multiply top and bottom by x minus 1. So if I take, let's go ahead and say equals. If I take the negative 1 up to the top, it's going to be negative x minus 1 over x squared. Now I need to multiply, x minus 1, sorry. Now I need to multiply top and bottom times x minus 1. Okay. So what that is going to give us is negative x minus 1 times x minus 1, which is going to give us negative x squared. This is going to be plus x, plus x. And then this is going to be minus x plus 1. So negative x squared, these cancel, and then